Hello, welcome to this YLC tutoring video. Today we'll be going over this PDF where I write a fraction in numbers and words that names the shaded part. Well, it looks like the way a fraction works is that you name, well, in this specific case, number of shaded over total number. So in this case, you have 3 shaded boxes and 4 boxes in total, so you have 3 over 4, or 3/4. Here we have, this is basically saying 3 out of 4 of 1 is the number. You have 3/4. Alright, so this one has 1, 2, 3, 4, 5, 6. 6 on the bottom. 1 box is shaded, so we go with 1. 1/6. 1/6. Alright, this one has 5 boxes in total. This one has 3 shaded, so it's 3/5. This one has 6 boxes. And this one has 4 shaded, so it's 4/6. This one has 3 boxes, and 2 are shaded, so 2/3. And 2 out of 4, so we get 2/4. Alright, find the missing numbers. So basically, the way you try to solve these problems specifically is that whatever you do to the top, whatever you do to one of these numbers, if you do something to the top number, you do it to the bottom number. If you multiply the top number by something, you multiply the bottom number by something. If you divide the top number by something, you divide the bottom number by something, and vice versa. So if you multiply the bottom number by something, you multiply the top number by something. Basically, multiply or divide both sides, both top and bottom, if you multiply or divide. So, what we're trying to ask is, what times 3 over 6, what times 6, or what 6 is divided by to get to 2. So in this case, you gotta divide 6 by 3 to get to 2. And whatever you do to the top, you do to the bottom. So, you gotta... Oh shoot, sorry. That wasn't supposed to be there. Whatever you do to the top, you do... Whatever you do to the bottom, you do to the top. So, we divide the bottom by 3. So, we gotta divide the top by 3 as well. And 3 divided by 3 is 1. So, the missing number is 1. 3/9 equals to something over 3. Okay, so what do we have to do to get from 9 to 3? Multiply or divide? We got divide, so then we just divide by 3 again. And whatever you do to the bottom, you do to the top. So divide the top number by 3. 3 divided by 3 is 1. So the missing number here is 1. Alright, here we're missing a number. So something multiply divide by 2 is 10, something multiply divide by 1 is the top number. So what do we have to do to get from 2 to 10 using division or multiplication? We multiply by 5. So we got, if we multiply the bottom by 5, we have to multiply the top by 5. So this one's 5. The missing number is 5. Okay, 3 over 5 is equal to something over 10. So we gotta do something to 5, that's multiplication or division, to get it to 10. And in this case, we have to multiply it by 2. And if you do something to the bottom, you do it to the top. So 3 times 2 is 6. 6. That's the missing number. Alright, 2 over 4. We gotta do multiply or divide 4 to get to 12. What do? We have to multiply 4 by 3 to get to 12. And whatever we do to the bottom, We're gonna get to the top. We're gonna do it to the top. I know you're sick and tired of me saying this, but it's just how it is. 6 over 12. Yeah, that should be right. 6 over 5 to, whatchamacallit, to something over 10, like I keep on repeating, yada 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 yada. So, what do we have to do? We gotta multiply 5 by 2, and whatever we do to the bottom, we do to the top. You're right. So, 12. 6 times 2 is 12. So, 12 over 10. Missing number is 12. Alright. Compare the part of each group that is green, right? Less than... Compare the part of each group that is green? Man, who made these? Anyways, write less than, greater than, or equal to for each fraction, basically. Or for each underscore underscore. So, the way you want to compare fractions, which this is what these are, fractions, you want to make the bottom number, the denominator, equal to the other number's denominator. And then you can just directly compare the numerators. Now that's a lot of big words, so I'll give you a specific example. Let's go with 4 first, because he'll go with this. So 1 over 2, and if you don't see a divided by sign, that means it's just over 1, because anything divided by 1 is itself, right? So 1 over 1. So this doesn't work, because we have different numbers in the bottom of the fraction. This one has a 2, this one has a 1. We want a common denominator, or we want both of them to be the same. Now, how do we get them to be the same? We gotta multiply both of them, or even just one of them, so that their denominator changes to be the same as the other one. So that's a lot of big words. What do I mean? Well, what's the least common multiple of 2 and 1? What's that? It's basically just asking 2, 6, 8, 1, 1, 1, 1. Or 1, 2, 3, 4. It's saying, how much do you need to multiply each one of these fractions by to get them to have the same number? So as we can see, these are the multiples of 2. These are the multiples of 1. We need to find a matching number. And as you can see, both of these have 2. So so we want to get both of the denominators to be 2. Well, this one already has a 2 in its denominator, so we don't need to do anything. This one, it has a 1 in the denominator. So what do we need to get 1 to 2 using multiplication or division? We gotta multiply both top and bottom by 2. So now we can just directly compare these. 1 over 2 is something related to 2 over 2. So which one's bigger, 1 or 2? 2 is bigger, so 2 over 2 is greater than 1 over 2. So 1/2 is less than 1. And when you already have the same common denominator, you can just compare the numerators directly. So these ones, they both have a 6 on the bottom, right? So we can just directly compare these numerators. 3 is greater than 2, so 2 over 6 is less than 3 over 6. Okay, 2 over 2, 1 over 1. Because remember, if there's no, divided by 36 or something, you can just assume it's over 1, because anything divided by 1 is itself, alright? Okay, so what do we need to do? Well, you can multiply 1 by 2 to get 2, and then we'll have a common denominator. So multiply both top and bottom by 2. We get 2 over 2. So 2 over 2 is something related to 2 over 2. These two are equal, so we can just say 2 over 2 is equal to 1, alright? 3 over 4 is something to 1 over 2. Well, let's list out the multiples of 4. 4, 8, 12. Let's list out the multiples of 2. 2, 4, 6. Oh, we have a common multiple. So 3 over 4 is already has a denominator of 4. But 1 over 2, we need to multiply both top and bottom by 2 to get it to be 4. So 2 over 4. 3 is greater than 2, so 3 over 4 is greater than 1/2, alright? And you can do number 5, number 6 on your own. Word problems. Jack, Lily, and Mia each ate a different amount of pizza. Lily ate 3/4 of pizza, Jack ate 2/3, and Mia ate 5/6. Who ate the most pizza? Who ate the least? Alright, so this is basically just another comparing fractions problem. Let's just write all these out. So, let's list out the multiples of 4, 3, and 6. 4, 8, 12, 16, 3, 6, 9, 12, and 6, 12, 18, 24. What do you see are the common numbers to the multiples of 4, 3, and 6? They are 12. So, you need to multiply each of these fractions by a number to get their denominators to be 12. So how do we get 4 to be 12? We need to multiply by 3. So 3 times 3 is 9. 3 times 4 is 12, alright? And let's just label these. That was Lily's, that was Jack, that was Mia. Alright, 2 over 3, how much do you need to multiply 3 by to get 12? You need to multiply by 4, so multiply both top and bottom by 4. 2 times 4 is 8. 3 times 4 is 12. Alright, what do you need to multiply 6 by to get 12? You need to multiply by 2, multiply top and bottom. 5 times 2 is 10. 6 times 2 is 12. Alright, so now we have the same denominators in each fraction. We can directly compare the numerators, the top numbers, the numbers. Numerator, yeah. So, it looks like, well, 10 is the biggest out of all these numbers, so it looks like Mia ate the most, and 8 is the smallest out of all these numbers, so Jack ate the least. Alright, let's do 2 and 3 maybe, depending on how quickly I can get through this, because I don't want this to go 13, 14 minutes. Sam, Ben, and Olivia ran different distances in a race. Sam ran 5/8 of a mile, Ben ran 3/4 of a mile, Olivia ran 2/3 of a mile. Who ran the shortest? Who ran the farthest? Okay, Sam is 5/8. Ben 3/4. Olivia 2/3. So that'll be 8, 16, 24, 32. That'll be 4, 8, 12, 16. What I'm doing is listing out all the multiples of the denominators as they are right now. What is the common number? 15. Jeez. Well, I'll just tell you right now, that's a bit much to fit in, so it'll just be 24, I think. Yeah. 8, 16, 24, you gotta multiply 8 by 3 to get 24, so you gotta multiply both top and bottom by 3, so you get 15 over 24. Ben, 4 is in the denominator. What do we need to multiply 4 by to get 24? We need to multiply by 6, so that's 6 times 3, which is 6, 12, 18. Olivia, 2/3. What do you need to multiply 3 by to get 24? 15, 18, 21, 24. You need to multiply by 8. Alright, so 24. 8 times 2 is 16, so you get that. Who ran the shortest distance? Who ran the farthest distance? Now that we have the same common denominators, we can just directly compare the top numbers, the numerators. Alright, so 18 is the biggest, so Ben ran the farthest. And 15 is the smallest, so Sam ran the shortest. Alright. Well, you can try 3 and 4 on your own, because I think they're relatively simple enough, because they're basically the same principles. So, thank you for listening to this video. Hope you learned something.